Today we're going to be focusing on some spring development in Solidworks. And the idea is that for our project we have to create a fidget toy. And so the compression spring or the torsion spring, depending upon which way you would like to use the spring, is going to be developed with our SolidWorks tools and then 3D printed for testing. Again, this is just a portion of one of the projects that I was working on, just to give you an idea of where we're going today. But we'll start with a fresh, brand new project so you can follow along with your spring development. So we'll just create a brand new document here, a brand new part, and choose OK. So with this new part, the big thing is that we need to determine where we're going to create this spring plane initially, whether it's going to be on the top or the front or the right side. So I'm going to go ahead and choose the top plane and turn the top plane on. So we'll go ahead and right mouse click on top plane, show the top plane. And we want the top plane to be visible for our drawing. And what we're going to do is we're going to draw the diameter of the spring. So the first thing that we're going to do is create a sketch on the top plane. Let's see here, normal to, so it automatically created a sketch there. We actually don't want this sketch. We want a sketch on the top plane itself. So I messed that up, but that's okay. We'll create a brand new sketch. Let's exit this sketch and we'll create a brand new sketch on the top plane. And with this top plane sketch, we're going to draw a circle, and that circle is going to be based on the center point because it's always easiest to work on the center point. And we'll make this circle about 2 inches. So we can, again, type in our dimension as we're dragging it out and get a 2.0 dimension. Or we can ballpark it and then come back in and edit the circle size. So 2.0 is our circle size. And so, now that didn't work well, but that's okay. We're going to go ahead and edit this anyways to 2.0. And so this 2.0 circle, the 2-inch diameter circle, is going to be the outer edge of our spring. So this is the diameter of that spring area, and that's on the top. So now that we have the circle, we can go ahead and revert back to the features level. So we'll go ahead and revert back to the features level. And we're going to create a curve, which is called a helix and spiral. So the helix and spiral is created based on that first diameter. And with the helix and spiral, we've got some variables we need to work with. And the key is understanding what these variables represent. And we have the ability to define the variables or define our helix with basically 3 different variables: pitch, revolution, and height. And so it's easiest for me to explain using pitch and revolution initially. So the pitch is the distance, and let's go ahead and change our view so we can see this cleaner. We'll go to a front view. And so the pitch distance is the distance from the point on one coil to the point on the next coil below. So the distance here is 0.75. Okay, and that is the pitch distance between one coil loop. And it's saying that we have 4 revolutions, and the overall, again, 4 times 0.75 is a total height of 3 inches. And then the diameter is stable at 2 inches because that's what we drew the circle originally at. Now we could say that we want height and revolution instead. So the variable here, we can give it an overall height, how many revolutions, and it will calculate the pitch based on that. So it'll divide the 3 inch by the number of revolutions. So if we say we want 6 revolutions, it'll be a 1/2 inch distance. So the pitch from one point to the next is now going to be a 1/2 inch. And again, if you're using a compression spring, this is the distance that the object could compress minus the diameter of the actual spring material that you design for 3D printing. So you've got to take that into account in terms of the pitch distance. That's why I like working with the pitch, because the pitch is a key element of what you're working with. So the diameter of the spring itself is important because that gets subtracted from the overall pitch distance, and that gives you the distance that the compression will take place. And so we can control the distance, but again, as we control the pitch, the height changes. And so as a tool for, in this case, our project being a fidget toy, it's got to fit within your hand. So you've got to make a decision of how your overall height comes into play here. All right, so we're going to do a pitch distance of 0.60. I know it's kind of odd, but we're going to work with a 0.6 pitch distance here. And we'll choose OK. So now we have a spring that has a 0.60 between each of the coils. Okay, and we've got 5 total revolutions. We're not done yet. The next and last step of creating a spring is that we need to create a diameter of the spring coil itself. Now, whether it's a circle or whether it's a rectangle or whether it's a polygon, it makes no difference what the coil shape is, but the size of that coil shape is what's important. So the first step in getting that coil shape set is looking at what plane. Right now we have the top plane turned on. We'll go ahead and turn the top plane off. And I believe the right side plane is the right plane for us to use. Now, why is that? Because if you notice, our coil starts and ends on the right side plane. Okay, so that's important. So the right side plane coil positioning gives us the ability to locate a position on that right side plane environment. We're going to go ahead and create a new sketch on the right side plane. So now we've created a sketch on the right side plane. We have not. We need to choose a sketch tool. And now we've created a sketch on the right side plane. So the end of the coil is on this right side plane, and we're going to go ahead and create, I'm going to create a polygon. Now you can create a rectangle, you can create an ellipse, a circle. Circle's the most common because it makes it very easily and consistent. Polygon is also a good tool also to use. So I'm going to go ahead and create a polygon. That polygon shape, notice that I can't pick the end of that coil. Okay, so for us to actually locate this polygon, I'll locate the polygon slightly off the edge, and we'll create this polygon horizontally here. And with this, we're looking at the overall distance of this polygon. So in essence, right now it's 0.21. I'm going to reduce that to 0.1875. Or I can do 0.2. That 0.2 will work fine for our example here. So the overall distance of this polygon, which is going to be the diameter or the size of our coil wire, needs to be positioned. That center point needs to be positioned on the end of this helix. So what we need to do is we're going to go ahead and choose OK, accept that dimension. We're going to go ahead and select this point, and we're going to convert that entity or convert that point. And so let's see here. If I convert this entity, let's see if it works. We want the edge, and we'll choose OK. Now, we'll see how well this works, because now I need to add a relation between the two. So we're going to add a relation between the center point here and the end point here. And that relation is going to be coincident. Okay, so now we've got a coil. Now notice that it projected this coil as a black object. And that is where people get messed up, because a lot of times you'll project it, it shows up as a black object, but now we've got this object. By the way, finish and choose check mark on the add relation. Now with this, we need to create this. This is a generic spline. Now I can delete this generic spline now because it's served its purpose, or I can change the generic spline into a construction line, and I can just choose for construction and choose OK. So what that will do is that's just a construction tool now, and it's not going to be used in our next step, which is we'll revert back. Our next step is going to be into features and sweeping this shape, this polygon shape, around the spiral. So it's picked up sketch number 3 for our circle, sketch number 3 for this, and it wants to know what the profile is for the spiral. And there we have it. So now you can see how it took this shape and made the coil of that shape. And since it was 0.2, the coil's fairly thick, it's going to be robust, and it's going to be able to maintain. If you have a very thin size coil, it will fail if you're 3D printing with ABS or even PLA. Even though PLA is a little bit more flexible, it will fail over the usage time. So be aware that the size of this is important, and 0.2, 0.1875 would probably be about the smallest. You can go down to 1/8, but it will fail a little bit faster. Okay, so now we've got a coil. It looks good. We'll accept it. And the last step is that we need to put on some components for both the thumb and the hand for our fidget toy. So this is a pretty easy process. We'll go ahead and turn off the right side plane because we don't need that anymore. The visibility will hide that right side plane because now we have the end of the coil that we can use to put the sketch plane on. And so the end of the coil is where the sketch plane is. And what we're going to do is we're going to create a splined object here. Wrong view. Wrong view. We'll flip this around. There we go. We're going to go ahead and create a spline to create a shape of an object here. So we'll choose a spline. We'll pick a point here, 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 here. I don't want to pick on the object just yet. Pick off the object here, and then come down. And now at this point, we'll hit the escape key to accept that spline. We'll add a couple of additional lines so it completes the shape, one linearly across the bottom, and then connect to that data point. Now the advantage is that we can grab these spline points and adjust them. So the way that this looks and feels and shape, it was still in the line mode. So I need to undo that last step. Boom, there we go. And get out of the line properties. Now we can take and adjust the spline. And that's the advantage of using a spline, is that we can take these points. Now, this spline is going to take up a little bit of material on this coil because I want this coil to be embedded into this extruded spline shape. But I want the extruded spline shape to basically encompass the diameter of the coil. So a little bit larger than the diameter of the coil is where we want this spline shape to be. Okay, and we're going to try to keep this as level as possible. And again, the ends, you can adjust these, and that's the idea, is that you can adjust these ends and positions. So that way, the coil acts and reacts and looks pretty similarly. And you can use data points, like for example, you can see now that these are level. All right, so we've got this end kind of well shaped here. We'll choose OK and go into Features, Extruded Boss Base. Now the key is that we want to extrude it mid-plane. I want it to extrude in both directions. And so the distance of extrusion is going to be about 1.5 inches in both directions. So it's 3/4 inches out, 3/4 inches back. And you can see that it is embedding into the coil. And theoretically, I could actually embed it into the coil a little bit farther. And I could actually take this edge and extrude it instead of mid-plane. I can say offset from surface. I can say through all. There's a lot of different options to work with. I can also draft it, meaning I can taper it. So you can see that I can taper the ends. So that end is tapered and this end is tapered, and the middle is the widest part. So if I taper it by 10 degrees, you can see how I can taper the ends in. And again, the goal is to get it to about the same size as the coil. Why is that? Because you want your thumb or your hand about the middle, because you're going to compress this in this design. Now you can also, once we choose OK, we boss extrude here. So now we could actually put in, if we wanted to, we could actually put in another spline and cut out where the thumb actually goes to make it like a little indentation for the thumb. But that's the basic starting spot for this. Then you have to do another one on the top. But here's a little tip. To keep the coil stable, having a post in the middle and a hole on your top component will keep the coil stable. So the idea is that the coil will then compress and follow that post in the center. So that post in the center prevents the coil from moving right or left. You can make it move right or left. It adds another dimension to the flexibility. But again, the next step would be to create a sketch on the top, create a simple or another component to be able to compress with. And if you do want to create a post to maintain the rigidity of vertical movement as opposed to horizontal movement, you could create a post and a hole in the top object. So this object only slides vertically along the object. That's pretty much it on creating a coil and the embedded finger components that you're working with. Have a great day, and we'll talk to you soon.